Let's take a look at a bubble sort in C#. We're going to use debugging so that we can step through the code and get a better understanding of how the algorithm is functioning. Using debugging and stepping through code or algorithms is a great way to learn how they're functioning because you can watch the values of the variables as they change. So in this instance we're going to use an array, and in this case it's just an array of integers, and you can see that we have it set up so that it is unsorted and that we have a lot of the lower values to the right. What we will do is simply output the current value of what that array is before we run the sort routine. Now let's take a look at the code. First thing is we're going to create a variable called swapped, and it's a Boolean variable, and we use it to know when we have completed our sorting algorithm. And again, if you remember from the discussions around bubble sort, we have to iterate through the entire array multiple times until the array becomes sorted itself, bubbling all of the smaller numbers up to the top. So swapped will allow us to know when we have successfully completed iterating that array for the number of times required. So initially we're going to set our swap value to false because we want to have at least one pass on the array. We know that it might be sorted, but we want to at least run through the array one time to verify that. And then we will step into the loop and we will iterate through the array, taking a look at the values, comparing them, and swapping them if necessary. Let's go ahead and click on Run and see how this works. Alright, so the console windows disappeared briefly because we've hit the breakpoint, and this is where we're going to start stepping into all of our code. And we can see that we're set to false, so we will actually iterate through the loop. The reason why we're using that is because we have a do loop here that says we will continue to run this internal for loop while swapped equals true. So once swapped gets finally set to false at the end of all of our iterations, then this do loop will stop. Alright, so we have swapped equal to false. Let's go ahead and step into the code, and the first thing we do is in our for loop we're going to initialize our counter variable, and then we're going to validate that against nums.length -1. The reason we're doing this is because we don't need to do a swap on the last element once we have completed all of our iterations. So if we step into the loop, we're using I for the position in our array. So we're saying if the value at the ith position in nums is greater than the value at ith position +1, we need to do a swap. Now let's take a look at how we can monitor our variables here. I currently equals 0. We said that we initialized it here to 0. So we're going to start at the beginning of array. Remember, arrays are 0 based. If we expand our nums array here in the autos pane, we can see that 0 will be the value 5. So we're going to compare 5 to see if it's greater than the value at 0 + 1, which is the position or the index 1, the value 10. So we're comparing 5 against 10. Is 5 greater than 10? Well, we know it's not. So let's watch as the code steps over that entire if routine because it evaluated to false. We iterate our I. So again, remember how your for loops function. The I becomes iterated at the end of that for loop. Then we come back and do a comparison to see have we reached the end of the array -1. Not yet, so let's go ahead and do another comparison. Now in this case we see that I has been incremented to 1. That's what our iteration does here. And then if we take a look at the values, we see that we are going to compare nums I, in this case, which is at index 1, or the value 10, against I + 1, which would be in this next array position, which is 3. Obviously 10 is greater than 3, so let's see what happens. We step into the loop because 10 is greater than 3. So the first thing we do is we set up a temp routine. Now notice that we say that this is a swap routine. This could be a completely separate method that we call, or we can do it inline such as we've done here. So temp becomes a variable that we're going to use to hold on to a value so that we don't lose it. When we're doing the swap, we have to have some place to put a value as we replace it because we don't want to lose it. So temp will become the value that is in I + 1. So in this case, when we iterate over that statement, temp now holds the value 3 because that was the one that was at array position or index 2. Now we say that that value or that position where we were in the array should be equal to the previous value. So this is where the swap takes place. Now we have taken the value that was at position 2, which we knew was 3, and we have replaced it with the value that was at position 1, which we know to be 10. And because we didn't want to lose the value 3, we now set nums I, or the value at position number 1, index 1, to the value 3. Let's iterate that so that we know that's taken place. We have swapped a value, so we set swap to true. Therefore, we continue with our loop. We now step out of it. We increment I, do the validation again for whether we need to continue the for loop or not, and then we'll continue on. Before we do that, what I want to show you is if we look at the nums array now, we can see that 10 and 3 were indeed swapped. So this algorithm will continue until we have no more values that need to be swapped. So we've already evaluated again. We've done a swapped equals true. We come back up, we iterate I. If we look at our array one more time, we can see that we have swapped 10 and 2 because the values 10 was greater than the value 2. So we're doing this iteration over the array. Now what's going to happen by the time we have completed this first inner loop, we'll see that we end up with an array that is partially sorted. Okay. So now that we have completed that, we've kind of done this partially sorted array. If we take a look at it, we can see that we have 5, 3, 2, 4, 10. That's a little bit different than what we started out with, which was 5, 10, 3, 2, 4. So really what we've done in this first iteration is we have taken and swapped 10 and 3, and then we have swapped 10 and 2, and then we have swapped 10 and 4. So this was the first iteration. We're not finished with this yet because we have to continue until all of these values are in a sorted array. So this loop will continue until we have no more swaps. Once we have no more swaps, this evaluates to false, and our do while loop stops executing, meaning that we are now completely sorted. So all we're going to do now is just simply let this continue all the way through until it has finished, in which case now we're done. Our console window pops open again, and we see that we have 2, 3, 4, 5, and 10. So our swap has completed successfully, even though it has taken multiple iterations to get to that point. So we swap 10 and 3, then 10 and 2, then 10 and 4. Then, as we went back through it again, you would have noticed if we went through each iteration, we would have swapped 3 and 2 and 3 and 4. So we could go through it individually, but you get the general idea of how this bubble sort routine is working. Even though we call it bubbling up the lower values, or the bubble sort sometimes is referred to as bubbling up lower numbered values to the left, technically what we're doing in the swap is we're moving the higher values to the right.